Welcome to another episode of the Tech Transfer Podcast. I'm Dave Brown, and I'm here with Jono Gal, who's an inventor and also a licensee and entrepreneur working on algae technologies, which are fascinating and something that most of us don't know a lot about yet. So, Jono, will you introduce yourself and tell us a little bit about photosynthetic technologies and why you founded that?
Okay, so my name's Jonathan Gal. I'm a PhD student in the Bio department at BYU. That's microbiology and molecular biology. I came here to not only to get a PhD, but also to work on some ideas that I had for innovations related to photosynthetic cultivation of photosynthetic microorganisms. This is generally done in a piece of equipment that's known as a photobioreactor, abbreviated PBR. This is a topic that I've been interested in for many years. I have a previous startup experience in this area, which never got off the ground. And I came here to BYU to try again. And I'm about halfway through my PhD program here at BYU. I have an undergraduate degree in biology from Harvard. I also have an MBA from a small private school back east called Babson College. I'm in the lab of Dr. Stephen Johnson, who's kind of a legend, at least here in the department. And he's also a friend of mine. We've been in the same ward for over 12 years now, coming on 13 years. Our kids, our friends, grew up together in the ward, and so we've known each other a lot longer than I've been here.
And can I ask you for just a primer on algae farming? So these reactors, I think, are tubes, right? And
Yes.
tell us a little bit about why someone would want to farm algae, what they do with it.
Okay. So originally, this industry started out in the 1970s, thereabouts, and they were growing algae in open ponds. These are sometimes referred to as raceways. It's just an oval-shaped man-made pond, and it has a paddle wheel that just continually turns and keeps the water circulating. The algae is grown in that and then harvested and processed and used for any one of a number of different applications. You can make biofuels out of it. You can make farm feed or fertilizer products. You can also make nutritional supplements or nutritional ingredients, as well as cosmetics and a number of other things. So one of the problems with the open ponds is that they are open, and that means that all kinds of stuff can land on the open pond and contaminate the culture. And contamination can be anywhere from totally benign and innocuous to toxic, to a threat to human health. And so because of that, there's been a shift more towards building these tubular photobioreactors. These are closed systems. The growth happens inside a tube, and this helps to prevent contamination. It also gives the producer a lot more control over the culture conditions. Something that is also lacking in the open pond setup. And that has become, I would call it, an industry standard over the past couple of decades. The industry's been growing, not super fast, but single-digit growth consistently for the past couple of decades, primarily with these tubular photobioreactors. So my idea is to introduce a new kind of tube. So instead of the standard round tube, what I've designed and had manufactured, this is a custom extrusion. And this gives you a sense of what's different about this tube compared to other tubes. So you'll notice the corrugated shape of this tube it increases the surface area. So the light is coming in. These are photosynthetic microorganisms growing inside the tube in water. And as the light strikes the tube, this configuration of tube increases the surface area by more than 2x compared to a round tube of the same size. By increasing the surface area, we have now demonstrated in the lab here that it does in fact increase the rate of production of the rate of photosynthetic production that is occurring inside the tubes by about 41%. We did a controlled 10-day trial here in the Johnson lab. We repeated it 4 times, and we had 2 statisticians from the statistics department here at BYU come over and analyze the statistics. They confirmed, in fact, that 41% difference was, in fact, statistically significant and attributable to the difference in the shape of the tube compared to a standard round tube. I have here in front of me, these are the actual prototypes that were used, or the actual models that were used in that trial that I just described. This one, of course, is the prototype of the new shape. This one is the control flask that was used as a control for comparison. And so in this one, in 10 days, we produced 41% more biomass growth than we did in this one.
And I think you and I were discussing this is growing rapidly in Asia. In China, we were saying there's a 50-acre farm that's just full of tubes like this. And so if you have some huge operation, people are investing a lot of money like that. If you can increase production by 41%, that is huge.
It's big, yeah. And if you're familiar with what a financial statement looks like, for example, an income statement, that increase in production shows up on the top line. So you get a revenue boost of 41%. The cost of goods remains about the same. And all the other lines, all the other expense lines on the income statement stay about the same. So that 41% flows down the income statement. And if you compare the pre-tax profit of that 41% advantage to the control tube, you actually see a 410% increase in the pre-tax profit in a hypothetical model that I produce.
See, this is why it's so great to have a PhD and an MBA. So you have all the financial stuff worked out.
Yeah. I definitely am glad to have an MBA before coming to this, because I just feel like I can innovate better towards the application of the product, having MBA in hand.
Yeah, and I should mention that the tube, the shape of the tube, the design, everything, that's all patent pending. So these are proprietary technologies that the company's commercializing. So there were a lot of things going on back in the early 2000s. You worked on a company, maybe the industry wasn't ready. There was financial tumultuous changes at that time too. And that now we're at a time where conditions are much more favorable and you have this proprietary technology. How does the PhD work come in? How do you decide to come back for a PhD?
Well, the PhD program here at BYU, at least in this department, is very generous financially. So Dr. Johnson was able to offer me a complete, fully paid scholarship for my PhD, and that also comes with a take-home stipend to help offset some of the risks involved with doing something like this. Within a couple of months of being here, he also applied for a grant for funds to actually work on the project itself, and he succeeded in getting us a $20,000 grant from BYU, which helped fund some of the prototype work and things that I've been showing you here. This tube, in fact, was made by a custom extruder and paid for by that grant. And I've got a bunch of other equipment and stuff that's been paid for by that grant. So BYU has been tremendously helpful financially and has also given me just really a new sense of hope and opportunity after experiencing a failure in this field earlier in my career.
I can imagine that at some point there would probably be government grants that could apply as well. Why are people, from a government perspective, why is it important to invest in this sort of technology?
From the government perspective?
Mm-hmm.
Well, photosynthetic microorganisms can be used for a wide variety of applications. The first I already mentioned is biofuels and bioplastics. So the photosynthetic microorganisms include a certain percentage of oil in the biomass. That oil can be used to create biofuels. It can also be used to create bioplastics, and can be processed in a number of different ways, probably for other applications as well. There's also protein in these products. That's actually the component of the biomass that's of most interest right now, particularly in countries like China and India, where the population density is much higher than it is here in America. With a tubular photobioreactor on an acre of land, you can produce 200 times more protein per year than you can by running beef cattle on that same acre of land. So it's a way to increase protein productivity to feed a large population like they have in India and China. In fact, as a result of this, India and China have invested a lot more as governments into these kinds of projects than America has at this time. But America is putting money into these things as well.
Well, and so this past year, there's been a lot of media coverage, memes online about us eating bugs in the future, right, for protein. So this is an alternative. You could eat algae instead.
Yeah. And in fact, this is not a new idea. There are tribes in Africa that have been studied, and they have been eating photosynthetic microorganisms as a staple food source for centuries. There's tribes in Africa that are known to have done this, and also tribes in Central America and South America, where it's known that spirulina, for example, has been used as a protein source for many generations in those cultures.
Well, spirulina you'll see in like protein shakes and things now, right?
Yeah, I mean, most Americans anyway, the idea of eating algae sounds pretty disgusting, but it can be used, and the protein can be extracted and just used as an ingredient and processed into food products that also have flavors and other attractive features that are put in there by the food processors. So it is gaining some traction in the West as an ingredient for foods, things like shakes and other kinds of. My wife, a couple of months ago, she brought home a packet of pasta that was made from spirulina.
Oh, I think I've seen that. Yeah.
It not only had a lot more protein than regular pasta, but that pasta also had a very high fiber content, which if you're into nutrition and dietary supplements and that sort of thing, you know that dietary fiber is a very healthy component of any diet, really.
Well, and the best protein bars don't just have a lot of protein; they have a lot of fiber too. You got to look for that.
Yeah. Fiber is very important to the diet, and a lot of Americans don't realize that the sugar, our sugar consumption is much too high. Fiber is much better for the body than sugar.
Well, that's interesting. So you've done these proof of concept studies in the lab to see if the new design produces more, and it does, 41% more. Are there any other things you've learned from those studies, other findings that will go into your business plan?
I would say the things that I've learned from that are mostly new ideas of future products that I sort of have to put on the back burner and put into the R&D pipeline, so to speak, to work on in the future. What I'm really focusing on in the near term is trying to launch this kind of tubing, and then my hope is that after getting some sales of this tubing, I will then have some profits that I could reinvest in some of those other new ideas that I've been picking up as I go along here. I don't really have a shortage of new ideas. That's not a problem for me. They spit pretty quickly to me.
Yeah, and for the existing algae tube, if all you did was get maximum market penetration with your current product, what size of market are we talking about, do you think?
So the data on this market are not easy to come by, but my best estimate of the money spent per year on capital equipment for producing or cultivating microalgae is in the neighborhood of $50 million a year.
Yeah, so far, right?
The actual spend on the organisms themselves, or the biomass themselves, is has been estimated in the neighborhood of around $1 billion a year. Yeah, I mean, the capital equipment lasts for 10 years or so. So you don't need to buy that. The producers don't need to buy the capital equipment every year, right? So, they might buy it once every 10 years or even less. And so I figure that market is approximately $50 million a year.
Okay. And this could be a situation where it's like alternative energy, like windmills or something. Once you make it efficient enough, then demand should increase. Probably the investment would be way higher if they could get 41% more production.
Yeah. Well, as we discussed before, that 41% increase in production can lead to a 410% increase in the profits. If that bears out, and has yet to be proven, but if that bears out, I expect that is going to trigger a significant uptick in the growth rate of these production companies and in the industry as a whole. I like to look at it a little bit like Intel launching a new chip back in the day. This is before Intel sort of lost its dominance and Apple started making its own chips. But back in the 70s and 80s and 90s, every time Intel launched a new microprocessor chip that had better capabilities, the industry would have this new wave of growth as everyone upgraded and all the applications became more powerful and new software came out and everything grew every time a new chip came out. It was the chip that really triggered that growth. I'm looking at this tubing as kind of like launching a new chip. It's a key component of a photobioreactor. It's probably 40 to 50% of the cost of every photobioreactor that's built, and it's the component that has the biggest impact on the production rate of the photobioreactor once it's built. So if we can stimulate the growth by that much and increase their profits by that much, I think we're going to see kind of an uptick in the growth rate of this industry.
Yeah, that's great. So creating any physical product is hard. Like you have the prototype there, you've created this thing. What were some of the challenges you ran into? What was hard about it?
Well, this was my first time working in a lab in many years, because I have an undergraduate degree in biology. I worked at the National Institutes of Health as a lab technician, but then I got an MBA and I had some business experiences. And so when I came here to BYU and came back into the world of molecular biology, I had to sort of shift gears and get back into lab mode, so to speak, because I had been in business for a number of years. So just kind of adjusting to life in the lab was a challenge, but and there were also some specific technical issues that I ran into as I tried to create this assay or build this assay for the comparison experiment. I hit the books. I was going to the library a lot, and I was just trying to figure out the answer or the solution to these different technical issues that came up. And eventually I did solve them, and I got the assay working, and we did have successful run of experiments. So it was just through doing homework, really, that I got through those.
Yeah. And there's a little bit the Elon Musk management model, right, where be the CEO of the company, but you also should understand the technology thoroughly and be driving that, right?
Yeah, I mean, I'd been doing a lot of reading of the scientific literature before I came here to BYU. I approached Dr. Johnson with a draft of a paper already written, and I think that was kind of the hook that got him to open the doors of this lab to me. But I still had a lot to learn once I got here, and I continue to learn while I'm here. It's a wonderful learning environment, and as I said, I have no shortage of new ideas. And it's been a lot of fun too. I like doing science.
Nice. Then on the business side, so you're leading photosynthetic technologies. What's next for the company? What do you see as the steps?
So we're planning to launch a marketing campaign in the fall of this year, probably in September. And this will be announcing the availability for purchase of tubing like this It won't be exactly like this. It'll actually be made out of acrylic instead of PVC. This one is made out of PVC. But we'll also be making a handful of components, or I should say fittings, that go with the tubing. So if you have tubing like this, you're going to need things like elbow pieces and adapters and connectors, the kinds of components that you'd find if you went shopping for PVC tubing to repair your plumbing. There's all kinds of fittings that go with the tube. So we're making especially designed and custom manufactured fittings to go with this tubing. And that will all be laid out and announced on the new website, which will be announced in September. And we'll see where things go from there.
Well, I should say most of the things I learned about the algae industry are from following you on LinkedIn. So that's probably right now the best way that people can get on top of this, right?
Well, that's what I try to do. I share a lot of information and I try to make it educational. One of the other things I do here as a PhD student is teach. And I've really been enjoying the teaching aspects of things here at BYU. And I try to share a little bit of that with the rest of the world through my LinkedIn account. So I hope you're learning things, and don't be shy about asking questions either.
Yeah, for sure. Thanks. It's interesting. So there are other people who are grad students working in labs on campus who might want to do what you're doing. They want to license the technology, start a company. What's your advice to them?
Well, do your homework. That's probably the best way to sum it up. An ounce of planning is worth an ounce of prevention is worth a pound of cure. An ounce of planning is worth a pound of results, you might say. So spend more time planning and thinking about it before you actually start doing things either in a lab and especially if you're going to be using any of your own money to try to build a business, be very careful with how you spend your money in those early days. It's a very risky thing to do.
Uh-huh. And so you had done a few things, like you've been in business, you've had a couple other degrees before you came back and worked as a PhD student and launched this company. So many students are good at launching companies because it's kind of a less risky part of life. They don't have a family and kids yet. How have you navigated those complications?
Yeah, so I mentioned that I went to Babson. Babson is very well known in the business world for its entrepreneurial education. In fact, it's been ranked number one consistently for many years in the study of entrepreneurship. And this is one of the issues that we talked about a lot in some of my entrepreneurship classes at Babson. How do you balance entrepreneurship with your life? And every entrepreneur's got their own story to tell on that. I was at Babson in the late 90s, which was a period of boom time in the internet industry. The mood, I would say, at that time was go for it. And do it before you have kids so that you don't have to worry about that conflict between the pressures of parenthood and starting a business. And then you can, have your kids later in life. That's kind of an aggressive approach. And I think that was born somewhat out of the culture of Babson, but also out of the times. We go through very different times in this country, economically speaking, and the different times that we're in can have a significant impact on your approach to risk and to answering questions like this. In the late 90s, people were starting internet businesses by just throwing together a PowerPoint presentation and showing up at an investor's office and getting handed a check. Literally, it was that simple. But the market's not always like that. In fact, it's usually not like that. That was a kind of a rare period of a huge tech boom. So every entrepreneur is going to have their own approach to how they handle those issues. It's kind of an individual thing. It's very personal. But I would say the most important thing is to have your wife or your spouse and your family on board with whatever decision it is you make, and make that decision together rather than being at odds about that decision. being at odds about that decision can create a lot of turmoil in your life. And when you're trying to start a new business, the last thing you need is turmoil in your family life, because starting a business is hard enough on its own. You need your family to be supportive, helpful, and on board with it, rather than fighting you the whole way.
That's great. And you mentioned some of the BYU resources you've used to your benefit here. One is you had a great relationship with a professor that led to the PhD opportunity and so on. Well, what do you see as other resources that students should take advantage of?
Well, I'm in the molecular biology department, but I've also made quite a number of trips over to the engineering building, where the BYU has a wonderful prototyping lab down on the first basement floor of that new engineering building. You can actually go down there and you can get 3D printing done. They have a machine shop, woodworking equipment. You can build things down there at very low cost. You do generally have to pay for your materials, but if you know how to operate those machines, or you can round up an engineering student who knows how to operate those machines, you can get things built there. Not everything, but you can get things built there at very low cost. So BYU shoulders some of that risk through its educational programs and a facility like the prototyping lab in the basement of the engineering building.
Yeah, it's beautiful what they've set up down there, and they have so much equipment. It's really fun to see, and it's meant to be kind of a maker space. For the students who do the Student Innovator of the Year program from the College of Engineering, they're also given a budget. I think it's $500 to pay for materials and things, so they can take advantage of that. Just great.
I mean, BYU doesn't have everything. For example, an extruder, machine. It would be nice if we had an extrusion machine here too, but I guess that's considered a little beyond the budget of the prototyping lab. But so I had to go off campus for this, but I have been able to use that prototyping lab a number of times, and also made some new friends there as well. So it's been very, very good.
Okay. Well, fantastic. Well, we're just about out of time, but best way to learn about photosynthetic technologies right now is LinkedIn. And then there's a website coming in the fall. Is that where we're at?
Yeah, a new website, I should say. That there is a preliminary website that's already up. I'm revamping it, building a new one, and that will be advertised and spread around a little more aggressively starting in the fall. Yeah, and then I have a number of experiments ongoing here as well that are going to be supporting the use of the alga tube. So these aren't experiments for new ideas or new products, but these are studies showing how well the alga tube works in various different situations. So I've got those things. We can look forward also to results from those things coming out soon.
And if people want to be involved, if they're excited about this seems like a make the world better technology that will get out there. So if people want to be involved, most entrepreneurs say they're always raising money. Are there investment opportunities, or are you looking up for partners at any level?
I am always open to discussion, and no one should ever feel shy about approaching me. I can't make any promises right now about how things will go. A lot depends on how this launch goes. I'm going to be launching, or at least doing a preliminary launch or a small scale launch myself. But I am definitely always open to discussion with other people. And if there's anyone who's interested, I would definitely encourage you to contact me, send me an email, or contact me through Dave. I welcome, any inquiries.
Okay, perfect. Well, hey, Jono, this is super interesting. I learned all kinds of things from you here today. So thanks for taking the time, and good luck as you roll out the product this fall.
Thank you very much, Dave. I appreciate your support.
You bet. Take care.